Okay, if f is this and g is this, then what is the derivative of f of g of x at negative 2? All right, so basically what they're saying is take the derivative of this and plug in negative 2. What's the instantaneous rate of change of this at negative 2? Now this statement is a composite function. All right, this is a composite function. Now could you right off the bat create this, which I could, watch this. I could write the function as f is the outside, so it is going to be 7 minus blank, and inside of that blank I could put g, which is 5x plus 1. That is the function. Okay, now I could clean that up and take its derivative. Okay, I could clean that up and make that negative 5x plus 6 and take its derivative, which actually probably would be fairly easy. All right, that probably would be fairly easy. Actually, let's just do it. What that derivative would be, so the derivative of this, if I'm taking the derivative of this, all right, that would be 1/2 goes out front, leaving the negative 5x plus 6, dropping the power by 1, and then multiplying by the derivative. That would be the derivative. And then if we're going to plug in negative 2, we could have, that'd be negative 5 over 2 times the square root of negative 5. You plug in your negative 2. Let's see what we get here. That would be negative 5 over 2 times the square root of 10 plus 6 is 16. So that looks like we got negative 5 over, this becomes a 4, so 2 times 4 is 8, so there's my answer. That would be your answer. If f prime is this and g of x is this, then what is g prime 3? It wants the slope of this function at 3. So let's go for it. First we have to take g prime. So the derivative of g prime, well, here's g. Well, do you see the outside? Do you see composite? So won't this be f prime, take the derivative of the outside, leave the inside. Are you okay with that? And then take the derivative of the inside. All right? So what does all that mean? Well, could we now technically, to find this, could we, don't we want to do it at 3? Aren't we doing this at 3 now? So watch. If I plug in 3, won't that be g prime 3 is equal to f prime of 2 minus 3 times 3 times negative 3. So won't g prime 3 equal to f prime, if I do all that, won't that be 2 minus 9, which is negative 7, times negative 3? And you're like, okay, great, but how do I finish this? Well, isn't it right here? Can't you find f of f prime negative 7 right here with this function? Just think about that. Can't you use this function to prime f prime negative 3? So I'm going to go back to this function right here. Okay, this function, bring it right over here, is good. If I want f prime, sorry, negative 7, that would be 3 times negative 7 squared minus 5 times negative 7. So f prime negative 7, because that's the number we want, is going to be 3 times 49 plus 35. Okay, so 3 times 49, that's 147. Okay, plus 35. So 35 plus 147, that would be, boom, that'd be 182 it looks like. Hope I didn't do that too fast. So the answer, g of prime of 3, is equal to 182 times negative 3. Okay, so now we got to do 3 times 182, that'd be 6. That would be 8 times 3 is 24, and that would be 546. So g prime of 3 is equal to negative 546.